took me back to Boston, my old stomping grounds. I did residency across the way at MGH with Harza, was an intern, and now back in California. And what I want to kind of impress upon the crowd today is just to think about how quickly things are moving and how you might leverage fast-moving technologies like this slide as we try to innovate in healthcare. And clearly we have a lot of challenges across the board, particularly with the aging demographics, with how we don't even practice evidence-based medicine, how we don't efficiently use the information we have, and particularly even need to innovate the process of regulatory, which is often stifling some of the innovation we're talking about. So, there's many, many exciting things happening in sort of the high-tech realm of healthcare, and that can actually sort of trickle down not only to the first world, but the third world, and I want to talk about how we might apply those. I think particularly when I say talk exponentially, my favorite example is that of the mobile phone we have in our pockets. It clearly progressed pretty quickly. It was junior high school. We're now clearly in the era of the smartphone, which is now really becoming, as we all know, really a medical platform. And I think there's like over 20,000 different apps available today. And other exponential things are tying into these things for the ability to load our genome on the phone, or point-of-care proteomics, or blood glucose monitors, as we just saw in an earlier talk, or the imaging imagery that can affect our own cognition. So I've been delving a bit more into this as a side gig, teaching at Singularity University, where we think about exponential. So if you take 30 linear steps, you go 30 steps. 30 exponential steps, you basically get to 1 billion total steps. And many trends in healthcare can come, and technology can come together to affect healthcare. We've been looking at this at NASA Ames at a new program called Singularity University. Several faculty actually here, Andrew Hessel included. We just ran a program a month ago called FutureMed. We'll do another one in May, looking at how do we put these things together and see where the trends are going, particularly with the explosion of data. One example of using better imaging in data is the ability to real-time fMRI, find a lesion, hit it with an array of ultrasounds, and knock it out. This is a combination of real-time imaging and ultrasound. Other examples are potentially replacing the standard angiogram with a real-time CT scan, upload to the cloud, do very rapid cloud-based fluid dynamics, and completely replace virtual angiography to determine whether someone needs a stent or not. So the paradigm shift is really happening in digital health. We're now in the era of mobile health, digital medicine, electronic medical records, all somewhat converging. And this is an opportunity as well as a problem. How do we manage all this big data and make it useful? I think most clearly this is going to become I think most powerful with the evidence or era of AI and Watson. Dr. Watson, we had a session earlier today discussing the opportunities there, particularly in the era of, as a clinician now, how do I take all this information and make it actionable? Some early examples of this are even available as an app, and this will disintermediate, I think, feels like radiology and dermatology, where you can take some standard selections like looking and doing pattern recognition and making better early diagnosis, which might save lives. And where this becomes powerful is integrating all these small apps and simple platforms to an integrated whole. And many people in this group are developing some of these platforms, and I think it's when we pull them together that it gets particularly powerful and inspirational. In terms of getting exponentially smaller, devices are shrinking, as you all know, to the point where we'll soon have sort of assisted living contact lenses that may be available for gamification, changing our behavior, what we see before and after. That will be here soon. Labs on a chip are already here today and are certainly being applied in the first world and soon in the developing world to do what used to take an army of technicians. Can be done on a chip at price point of pennies. We're certainly also moving to an era of cheaper, actually, in some realms. So the card used to, now, cheaper is not usually associated with medicine, but in genomics, for example, it used to be about hundreds of millions of dollars for a genome. Now you can buy a full genome for about $5,000, and soon that might be free, sort of like you pay for a phone service. So Lee Hood sort of proselytizes P4 medicine, predictive medicine based on your genes. You can do prevention and personalized prevention based on that, and then it can be participatory, such as we've seen from our friends here, patients like me and Cure Together. As we pull these trends together, I think we can affect healthcare. In my realm of regenerative medicine, which I've done most of my focus, there's a lot of movement now replacing embryonic stem cells with those of induced pluripotent stem cells, turning a skin cell into a pluripotent embryonic stem cell, where those are converging are, for example, in the era of 3D printing. So we can now basically scan a leg and 3D print a leg, or just last month announced the first synthetic sort of trachea made from patients' own stem cells, and I think we'll move to an era of eventually 3D printed products. So as we think about healthcare and medicine at this conference and beyond, think about how really quickly things are moving along the exponential, how you can pull those things together in the realm of big data, miniaturization, home-based decentralization to sort of innovate and create a better future as we go forward. Thanks.